Hello. Today let's journey to the distant reaches of our solar system, far beyond the orbit of Neptune, into the icy expanse known as the Kuiper Belt. Our destination is a fascinating world named 50,000 Quaoar. This dwarf planet, completing an orbit around the Sun every 286 years, was already known to be a special case, hosting a moon named Quaoar and two distinct rings. But recent observations hint at a new surprise in its system, the very likely presence of a second moon. What makes Quaoar so peculiar is the location of its rings. Typically, a celestial body's rings are found inside a critical boundary called the Roche limit. You can think of this limit as a cosmic danger zone. Inside it, the gravitational tidal forces of the main body are so strong that they would tear apart any smaller object trying to clump together. This is why rings can remain stable there, but moons struggle to form. Outside this limit, the forces are weaker, allowing particles to coalesce and form moons. Quaoar defies this convention. Its rings are situated beyond the Roche limit, challenging our fundamental understanding of where rings should be and where moons should form. So how was this new discovery made? The technique is called stellar occultation. In simple terms, it's about watching a distant star's light get briefly blocked by a passing object. Imagine noticing the shadow of a tiny insect as it flies in front of a distant street lamp. The duration and shape of that tiny dip in light can reveal a wealth of information about the object that passed by, its size, its shape, and its exact location. On June 25, 2025, an event like this was targeted at the Miriam Oliver Observing Station in California. The plan was to observe Quaoar's known ring, Q1R, as it was predicted to graze a 14.9 magnitude star. Researchers expected to see a slight, brief dip in the star's light as the semi-transparent ring passed. But what they recorded was far more dramatic. Instead of a faint dimming from the ring, at 6:55:21 UT, they witnessed a near-total blackout lasting 1.23 seconds. The starlight dropped by 99.9% in the main telescope and 95.9% in the secondary one, the slight difference easily explained by contamination from a neighboring star. Both telescopes confirmed the timing of the disappearance and reappearance to within 0.03 seconds. The light curve profile was sharp, like a switch being flipped off and on again, strongly suggesting a solid, opaque object. The first step was to rule out more mundane explanations. Could it have been an airplane, a bird, or a drone? Impossible given the duration and depth of the blackout and the remote location of the observatory. An artificial Earth satellite? An occultation from one would last less than 0.1 seconds. An electrical glitch? All systems were running on independent power with no anomalies. What about an undiscovered asteroid? To produce such a long and deep event, it would have to be bright enough to have likely been discovered already, and calculations didn't match. Quaoar's known moon, Quaoar, was also in a completely different part of the sky from our perspective. In short, all Earth-based and random asteroid scenarios were eliminated. This left two tantalizing possibilities. The occultation was caused either by a previously unknown, extremely dense arc within a third ring, or by a new satellite. The ring arc theory has some problems. First, if it were part of a complete ring coplanar with the others, astronomers should have seen a second occultation a few minutes later as the other side of the ring passed by. No such event was detected. Second, highly sensitive data from the James Webb Space Telescope, JWST, from 2024 showed no evidence of any opaque material in the region where this hypothetical third ring would be. Furthermore, the near 100% drop in light would require an extraordinarily dense ring, an optical depth tau greater than 6, far denser than anything sampled in Quaoar's known rings. This makes the ring arc scenario less likely. The satellite hypothesis, however, fits the data remarkably well. The sharp, square wave profile of the light drop is exactly what you'd expect from a solid body. If the event was a central occultation, this new moon would have a magnitude of around 28, making it incredibly faint and invisible to all but potentially the JWST. Intriguingly, if this new satellite shares the same orbital plane as the rings, Its calculated distance from Quaoar would be about 5,757 kilometers. This is remarkably close to a 7-to-2 orbital resonance with the known moon, Quaoar, placing it in a dynamically sensible location in the system. So, what is the significance of this discovery? The ring and moon systems around small bodies are a frontier in planetary science. They are natural laboratories for understanding how planetary systems evolve. Why and how do rings persist beyond the Roche limit?